Hi, this video is designed to help you learn how to use a ratio table to find equivalent ratios. Ratio tables. A ratio table is a table of values that displays equivalent ratios. And equivalent means equal in value or amount. Here's an example of a ratio table that shows the relationship between soda and juice. The ratios 1/3, 2/6, and 3/9 are equivalent since each one can be simplified to a ratio of 1:3. We can also take a look at how we get from the beginning ratio of 1/3 to each of the other ratios in the table. Equivalent ratios express the same relationship between quantities. In the example above, for every 1 soda, there are 3 juices. And we can see that if we double the number of sodas, so we multiply by 2, we get 2. If we double the number of juices, we get 6. If we triple the number of sodas, we'll get 3. And if we triple the number of juices, we get 9. Those relationships are consistent across. We're multiplying by the same thing on the top as we are on the bottom. Here's an example of a word problem that you can solve by using a ratio table. To make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much food coloring should you mix with 5 cups of white icing to get the same shade? So let's use a ratio table. Since we know that 1 times 5 is 5, we can multiply the top by 5 as well to get that we need 30 drops of yellow to 5 cups of icing. So we'll add 30 drops of yellow food coloring to 5 cups of icing. You try. In a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. If he ate at a constant rate, determine about how many hot dogs he ate every 2 minutes. So we'll start with a ratio table. Notice that we're comparing the number of hot dogs to the time in minutes it took him to eat them. Divide each quantity by 1 or more common factors until we get a quantity of 2 minutes. So we're looking to make the bottom number 2 because that's where the time is. Well, I can recognize that each of these numbers is divisible by 2, so we're going to start there. When I divide the bottom by 2, I get 6. And whatever I do to the bottom, I have to do to the top. When I divide by 2 on the top, I get 33. Now we know we need to make the bottom number into a 2. So 6 divided by 3 gets me the 2 that I was looking for. Whatever I do to the bottom, I have to do to the top. And when I divide 33 by 3, I get 11. So Chestnut ate about 11 hot dogs every 2 minutes. Now you try using a ratio table. Remember, you can always pause the video so that you can do the problems and come back and see how they were done if you need some help and to check your answers. But let's take a look at the relationships that we know here. We need to fill in the missing pieces of our ratio table. We know that 4 times 2 got me the 8. That's the relationship I know. Well, if we apply that same relationship on the top, we know that the blank on the top will be 4. Now we go to the top relationship from 2 to 6. We know that we can get from 2 to 6 by multiplying by 3. Whatever I do on top, I need to repeat on the bottom, and 4 times 3 is 12. Then we look at the last example, and we know that the relationship is from 2 to 10, and I get from 2 to 10 by multiplying by 5. Whatever I do to the top, I have to do to the bottom, and 4 times 5 is 20. Now my ratio table is complete. If you were to simplify each of those ratios, you would find that they all simplify to 1/2. 2 is half of 4, 4 is half of 8, 6 is half of 12, and 10 is half of 20. They have the exact same relationship to each other. Here's another example. Remember, you can pause the video, try the problem, and come back to see if you got it right. Now in this case, we don't have a relationship at the front end of our ratio table, so we have to rely on looking backwards. So I have a relationship between 21 and 7. I can get from 21 to 7 by this time dividing by 3. So if we divide by 3 on the bottom, we have to divide by 3 on the top. And when I do, I get a 1. Now I have 1/7 as my first ratio, and I can use that ratio to help me solve the rest of the table. So 7 times 2 gets me 14. If I apply that exact same relationship to the top, I know that the number that's missing on the top now will be 2. And how did I get from 7 to 28? I multiplied by 4. Whatever I do on the bottom, I need to do on the top, and 1 times 4 is 4. Notice in this problem that we used both division and multiplication to get our answers, and each of those ratios can be simplified to 1/7. Here's a quick summary of ratio table information that we just learned. 1. A ratio table is a table of values that displays equivalent ratios. 2. You can use multiplication or division to solve for missing values. 3. You can use a ratio table to solve real-world problems by finding equivalent ratios.